Welcome to Reverse Engineering a Droid Personality Chip, Part 4. And it looks like there's probably going to be a Part 5. I apologize. I did not expect this to become such a long series. I didn't expect it to be a video series at all. I expected it to be a video, and now, well, here we are in Part 4. Anyways, in this video, we're going to look at the size of the PCB. The width was set in Part 2, but the height I never really set in Part 2. We're going to take care of that in this video. I also want to modify the footprint of the memory chip that's used on this PCB. I want to make it wider so it can accommodate larger sized memory chips. And I also want to add a footprint for a through-hole memory chip. By the end of this video, I want a PCB design that can accommodate narrow surface mount memory chips, wide surface mount memory chips, and through-hole memory chips. So that way you have a wide range of options available to you when you go to assemble your personality chip. So let's not waste any more time. Let's dive right back into where we left off with the last video. So I have been tinkering a little bit with what I'm calling this weaving on the bottom of the personality chip to connect all the fingers together. I find that I'll do a design, a PCB design, I'll go away, and if I return to it a little while later, a few days later, I'll want to tinker with the layout a little bit. It's just something that I do. You'll probably, if you try your hand at this, will probably find that you tinker quite a bit too. I also went back to the schematic and cleaned up the schematic a little bit, just to make things a little more easy to follow visually. But while I was doing all this, I realized I've missed something here that I need to fix before we can continue on here. And that has to deal with the memory chip. Now, the memory chip that I selected was the Puya chip, which is a 150 mil package. That number refers to the width of the chip. They also have the same chip in a 200 mil package. And then I know another company that manufactures flash memory chips that I've used in personality chips, a company called WinBond. They have similar type chips, but they have a 208 mil package. What I would like to do is make this PCB compatible with all of those sizes of flash memory chip. And the way I think I want to do that is I want to take the footprint of this 150 mil package, and all I want to do is take these pads here that you would normally solder the pins on the memory chip to, and I just want to lengthen them. So if I have a 200 mil package, they're long enough that there's still room for those pins to sit on the exposed copper to solder it to. And I also want to make sure that they're long enough to accommodate 208 mil package chips. So that means I need to take this footprint and edit it. So I'm going to go back into the schematic here. I'm going to click on this chip here, and I can come over to the right under custom attributes here, and I can see that I have the footprint up here in the search selection here. That's the name of the footprint that's being used, so I'm going to copy that, get out of here, and then if I go into library and if I go into footprint and I can search for it, you can see I've already done it. I made sure I was correct before I started recording. There's the footprint. Now I can come down here to the bottom and click Edit. There's the footprint. Excellent. And we can see individual pads here. On the right hand side we can see their properties as well. And we can see their center X and center Y positions. We'll need to remember all of this. We can also see that the canvas attributes, the units are in millimeters. I'm going to convert that to mil. So if we do a little math here, This is a 150 mil package. I want to accommodate up to 208 mil. Let's call it 210 mil just to make the numbers a little more round. So that's an extra 60 mil that I need to widen this footprint. So the pads on either side need to be extended 30 mil out from the center. So 30 mil extension on either side will add up to the 60 mil difference. That's the theory in my head anyways. So if I come down here and select these 4 pads, come over to the right, and I have width and height. Hopefully height is the correct dimension here. So that's 59. I want to add another 30, so that would be 89. Now the center Y has to be adjusted 15 mil. So it was, I added 30 mil onto each pad, and it expanded from the center. So it means that the pad expanded up 30 mil and down 30 mil, 15 mil in each direction. So now I need to move everything down 15 mil. So if I add 15 here, it's going to be to 7. That's what, 22? And that's move the pads down to where they need to be. So now I need to do the same for the top side. Make them 89, like so. And then the center Y, I need to add another 15 to make it 122. And there we go. This footprint has been updated now to accommodate up to a 208, or technically a 210 mil package. So I'm going to save this, but I'm going to need to save it as something else, something as a different footprint name that I can then refer to later. So I need to just give it a name that I understand. I'm going to call it SOP 8, and then I'm just going to call it with 3.9. These are in millimeters to something else. What do we want to call that? I'm going to break out my calculator here real quick. And actually, you know what? Let's use the help of Google. Google will help us. 150 mil to millimeters is 3.81. And 210 is 5.3. So I'm going to come over here, width of 3.9 to 5.3. I'm going to save that. Great. I'm going to close that. I'm going to come back here to this, to the schematic, to that memory chip. I'm going to come over here to footprint, and now I'm going to type in that new version. Look for it, and it found it. It's in my workspace. I'm going to select that. You can see the pins, or the pads here, are much longer now. Click Update. Click Update. Close it. Save that. Design, Update PCB. And it's going to replace U1 with the new footprint with the wider pads. So now we have a personality chip that can accommodate a wider range of footprints for the memory chip. So if you don't have the Puya memory chip, or if you can only find the wider versions of the memory chip, which typically the wider versions are used for chips that have more capacity to them. So if you want something that can carry 8 megs or even 16 megabytes of data, which that's an awfully big personality chip. I mean, we are talking hundreds of sounds there. But if you wanted to do that, you could now. We could get the bigger chip and put it into this footprint. Well, in theory, anyways. We'll find out when I finish this design and order them and go through a test run. Now, the next thing I do before I start connecting all of these components here is I want to finalize on the height of the personality chip. Recently I've been doing a tall version of the personality chip, which makes it much easier with just the USB to pull it out of ARD unit droids. If you used one of my older short versions, getting those chips out of ARD unit droids was a real hassle. So how tall does this personality chip need to be? After a bit of experimentation, I found something around just under 1200 mil. I believe it's 1180 mil is the height that you want to aim for. So I'm going to need to figure out how tall that is. And in Easy EDA here, I have a tool that, if I select the document layer here, I can use it like a measuring tape. I can click here and then start going up, and I want it to stay completely vertical like so, and I want to go up to 1180-ish. Correction, that's 1150. I just double checked my notes. There we go. So that's the rough height of what that chip needs to be. And expanding it is pretty simple. I'm just going to zoom in on this node and bring that up like so. Come over here, bring it up like so, and there we go. Now I have the personality chip, a design for a personality chip, an outline for a personality chip that's 1150 mils. That should be just about the right size. Now there's one other thing I want to add, again, before I start putting all these components in and connecting them up. I want to put those holes back into the board. Those 4 holes up at the top here that you can use to clip things onto or tie things to. They're pretty useful. So up on the PCB tools section here, there is this hole button. Click on that, and then you can place the hole wherever you would like. Like so. Well, here is the PCB design that I have on OshPark for version 1.3 of the personality chip. Let's take a look at what those holes look like. The holes have an 80 mil diameter, and they are located like roughly 40 mil from the edge. This is based on the grid size over here. So that's roughly what they are on my original personality chip. Okay, so we know they need to be 80 mil. They are. And now I want a distance of 40 mil from the edge. So right now I have a grid of about 25. So I'm going to change the grid size to, you know what? I'll change the snap size to 10. That's probably the better way to do it. 1, 2, 3, 4, or that line would be 5, so 4 and 4. 4 and 4. All right, 350 it is. So 200, 250, 300, 350. There. So now we have the holes where they need to be. I have the fingers set up. Now it's just a matter of placing the components onto the board here. And then we're done. A little time has passed. I've taken a break from working on this, and now I'm returning to it. And there's a couple of things, or one thing that I want to point out before we continue, which is what you won't have seen, but what I've done is I've changed this footprint for the surface mount memory chip a little bit more. There was a big notch here in the yellow silk screen on the footprint, and I made that notch much smaller, and this circle, which was on the outside, I've brought inside and made that that inner hole there a little bit bigger, a little bit more noticeable. The reason is I need to do that to do the next step, which we can get to right now. I want to add to this schematic a dip 8 footprint so that I have the option of either using a through-hole version of the memory chip or a surface mount version of the memory chip. There are a lot of different ways to add this socket to the schematic. I'm not going to say that there's any way that's more correct than not correct, at least not with Easy EDA, because to be honest, this is an area that I'm not entirely familiar with. But what I have found will work for me is if I go into library here, the search engine is either Easy EDA or LCSC Electronics. And if I click on LCSC Electronics, it gives me a list of different sections under which I can select components, and under connectors, there's a section called IC sockets, which I want a socket essentially for a DIP 8 component. So if under package here I scroll down to where it says DIP 8, apply the filters, and I get a single component, a single DIP 8 socket that LCSC is selling that I could then take and place on my circuit like so. Now I have a socket where a memory chip could go in. I just have to wire this socket up the same way that this surface mount memory chip is wired up. And then I update my PCB, and that will include this new socket into my design. There's a couple of things I want to do here, though. First, I want to change the name of this component to reflect what it's really for, which is just 25XX DIP 8. The name is useful to you, the original name, if you're going to order that part, which I'm not going to. So I'm just going to call it 25XX DIP 8, so I know what that is. The reference designator is SK1, referring to socket 1. I think I'm going to also give that a change and call it U2. And U1 and U2 are not going to appear on the PCB. I'm going to choose to hide them. But I'm going to leave it here on the schematic, so that way I know that this is intended to be an alternative to U1. In fact, you know what? I might call that U1 alt. Maybe that's better. That's probably better. Although it might be breaking some reference designation rules for some PCB manufacturer out there, but for our purposes, I think it will be okay. Okay, so to wire up that socket, most of those pins are going to be real easy. I can just click on the net port symbol that's connected to U1, copy and paste, and connect it to the same corresponding pin down here. Like so. Yeah, just making sure that that's connected. Write protect goes to pin 3. I don't have a net port symbol for that, so I can just hit paste again, paste a second copy of this serial output port, and then just rename it to write protect, like so. Good enough. And then ground goes to pin 4, like so. Over here on the right hand side, pin 8 connects to VCC. Pin 7 used to connect directly to VCC, but not anymore. Oh, this thing. Yeah, we'll leave it like that. Let me just get these out of the way. Pin 5 and pin 6, like so. Pin 7 is now the hold net, or connected to the hold net, which is between pin 7 and that resistor. So same thing as the write protect, I'm going to paste a net port from another pin and then just rename it to the net that matches what's up here on the surface mount footprint. And that should do it. I'm going to save that, go up to Design, Update PCB, apply changes, and I should now have, there it is, a DIP 8 footprint. Now there's a few things here I want to change, and we can see that it says U1 Alt. I don't want that, so I'm just selecting that and deleting it. Now I can bring this over here like so. And I'm going to try and fit the surface mount version within the area of the through-hole version, like so. You can kind of get an idea now why I needed to change the footprint for that surface mount version. This notch here would have come up over the exposed pad here, which I think most PCB manufacturers would sort of do a quick check and have fixed that for you, but you can't assume that. So it's good that the design file that you give the PCB manufacturer has stuff like this taken care of. You don't put silkscreen over exposed copper. It is going to get messy. So I no longer have that. Another thing I want to quickly change here. If you notice around the pins here of the DIP 8 package, there's this little purple halo. Same kind of halo exists around the surface mount package as well. Those pads have a little halo around it too. That, if I click on one and come over to the right here, refers to solder mask expansion. When the board is manufactured, the copper is put down first, or I should say the copper is etched away. The whole PCB will be one sheet of copper on either side, and then where you don't want copper, that area is etched away, leaving just the copper where you want it. And then on top of the copper, including the copper that you don't want to be exposed, they put a solder mask over it. It's like nail polish. And it just protects the copper and keeps it from being accidentally soldered to. When that solder mask layer is put down, if your board isn't correctly aligned into the machinery that puts that solder mask down, if it's off by a couple of mils, then the solder mask could creep over the copper that you want exposed. Osh Park, which is where I'm probably going to be ordering these boards from, recommends a tolerance of 2 mil for solder mask expansion. I could set it to 0. In fact, all my previous personality chips have had it set to 0. And there hasn't been any problems with that. But I'm going to follow the guidelines from Osh Park and set the solder mask expansion to 2. Okay, so with solder mask expansion taken care of, I think it's pretty much time to wire everything up. So I'm going to fast forward through the beginning here. What I'm trying to do is organize the layout, figure out where everything's going to fit. I'm using the rat lines, which are those little thin blue lines, as a guide to show me roughly where the different pads are going to connect to each other. That helps me figure out the orientation of the components. Do I need to flip them around? Just rough ideas here. I'm not by any means trying to come up with the final layout here. It's more of a roughly where things will fit before I start wiring them up. I'm going to have to run traces or wires from these 8 pins down to the bottom here. Now, I don't have to wire up all 8. Ground, I'm going to have a connection to on the back side of the PCB. I'm not worried about that. VCC only needs to come up to here, so I just need to wire this, bring this wire up to here somehow. Where I run into problems, though, is wiring up the serial input and serial output pins. Just as an example, there's VCC wired up. Now if I want to wire the serial output pin here, I'm going to come across VCC. It's not going to work. I'd have to find a way through, like maybe between two pins, which is possible if I were to change the width of the trace from 20 mil to 10. But then that's going to also get in the way of my connection between here, between this capacitor and this pin here, or pad here. So what if I bring that capacitor over here like so? Is that going to be too close? If I bring it down a little bit like that, I'm going to get rid of the silk screen here, just because it's getting in my way for the moment. And I could like throw a via, like right there, from that pad up to there. And then serial output can just come down here like that. Serial input, which is way up here. Serial input. I could potentially come down like that, but if I do that, then the clock pin, I'm not going to be able to connect a wire to that. Like if I came down like that, that could work, but now the serial clock pin, which I need to attach this capacitor to, isn't going to work quite right. So we'll fast forward a bit more here. It's like a giant puzzle trying to find ways to connect all these different pads together. You might be wondering why I'm not using the bottom layer of the PCB. It's sort of a rule that I've set for myself on this particular project. I want the bottom layer to be just one full solid copper plane. I'm going to have artwork on the back of the PCB. I don't want traces interrupting that artwork. I probably could have made this 1,000 times easier on myself if I allowed myself to use the bottom layer PCB to get all of these traces running together, to connect all of these components together. But that's the restriction or the goal that I have set for myself arbitrarily, so that's why I'm trying to keep all the traces on the top layer. So this is that point in the design where it's trial and error. It's sit back and spend the next couple of days looking at the design and try to figure out how to route all the traces in such a way that everything gets connected. For the purposes of showing you a quick and dirty completed PCB here, what I'm going to do is I'm going to select the back or the bottom layer, and I can take this SCK pin and run it out to here. Like it doesn't matter, it can go anywhere. Bring it out to here, right? Stick a via there, and then on the top layer connect that via down to here. That's connected. Again, select the background again, go up to this copper area, and this copper area is going to be called ground, and I'm just going to create a massive copper area on the back here, like so. And because it's part of the ground net, Easy EDA will automatically connect anything that's also part of ground. So if you look here, this pin, which is a ground pin, now gets connected to the copper plane on the back, as well as this via here, which is marked ground, and this via here, which is marked ground. So now everything's connected, because remember I had a disconnect between here and up top here. Well, now that copper background, or that copper plane on the back, is how it's connecting. It's connecting this hole here of the dip chip down through here, over to the ground plane over here, or over here. I can also add extra vias to connect to ground, so I could say throw in a via here, or here, just to connect everything to the ground plane on the back. But for now, let's not worry about that. I can save that and do a 3D view and get a sort of a sense here of how that board is going to look. Big copper plane on the back, except for that one little trace there that I needed to get the clock pin hooked up. Now this board, I could generate the files that the manufacturers need for this, and upload them to OshPark or wherever else, and get a few printed. And I am sure that were I to get those and assemble this board, it would work just fine. I mean, this is a fully working, probably ready to go board. I don't know it for certain yet. I would want to order some before I start telling everybody, hey, I've got a working PCB here, have at it. So what I want to do now, and I'm going to do this off camera, is I am going to play with the routing here. I want all of my traces to be on the top, except for the few down here at the bottom. I would like to have a big plane on the back here, a big copper plane on the back. So I need to try and figure out how to move some of these components around such that I have the space necessary to wire things up. So I'm going to save you sitting here with me for the next couple hours while I figure that out, and I'll come back and show you what I come up with. Okay, I think I am at a point here where I'm just about done. So let me go over just a couple of things here. You can see this dark blue region in the back. That is the ground copper plane. That's on the bottom layer. You can see, except for those I don't know what shape you want to call those, the weaving or the crisscrossing traces down at the bottom there. There's, let me turn off the silk screen. You can see there's a nice ground plane here. There are no traces running through it in the middle here. The way I have organized these components are, there's a couple of goals here. One, I wanted to limit the number of vias, which are these tiny holes here, in the PCB, in that big ground plane area. The reason being, I plan to put artwork there as the final touch before I finish this and send it off to get manufactured. And vias will be covered over with the solder mask. So in theory, they're not very visible. You can see them if the light catches the PCB just the right way. You can see where all the vias are, but they'll be hidden mostly by the solder mask. But still, if I can limit the number of vias there, that would be nice. There are reasons to add vias to create shorter paths to ground for different elements. So for example, this is the ground pin way up here. Now the ground pin on the through hole element is essentially just a really big via. You can think of it. So there's a connection to the ground plane on the bottom layer there. But if I had just a surface mount chip here, I might want to put a via right next to the ground pad here rather than trying to run a trace all the way down here. Just connecting it directly to the ground plane on the back gives the chip a quicker way to ground. The electricity can find ground in a shorter way. It'll help with the performance of the circuit. In theory, anyways, on this PCB, which is very small, it's probably not going to have as big of impact as a much larger PCB where ground planes and or paths to ground and ground loops and all sorts of other stuff that I barely understand become really important. The other thing I wanted was an area down here at the bottom where I could put some kind of text, like this is a so-and-so personality chip, or this personality chip designed by me, or whatever. So I played around with the placement of the different components. I tried to move the memory chips up to create more space down below here, and then I rotated the capacitors C42 and C44 so they're horizontal, like you see, again creating more space down below. And if we go into a 3D view here, you can get a sense of what space I have available to play with. So I can put some text down here, a couple of lines of text very easily, flip it over, and I've got a place to put some artwork. Now obviously if you're trying to put artwork on the back here and you're using this through-hole version, these holes are going to get in the way. You're going to have to find a way to edit your artwork to cut holes into it that will match up or line up with this. Again, you don't want the solder mask or the silk screen to cover those holes. Those pads you are potentially soldering to if you're using a through-hole chip. So if you don't want the through-hole version, you could actually just delete the socket from the PCB design, and you could then rework the traces a little bit here to make things fit better and give yourself more room on the back here, more unbroken room on the back here to put artwork or whatever you want on the back. What else is there worth showing? You might notice this VCC trace in the middle here is narrow, whereas all the others are thick. That's because I am not expecting a lot of current to go through this middle pin. This middle pin here, again, is used just for detecting that a personality chip has been inserted. So I've gone with a thin trace there, but if you don't like that aesthetic, no problem. You can click on that and change it to a thicker trace. Up here, similar situation. I have a ground pad here, right? And that's going to this write protect resistor. Not a lot of current going through that resistor, just a very tiny amount, just enough to tell the chip to enable write protect. So I don't need thick traces here, so I don't have thick traces here. The same with the hold pin on the hold pin on the left here. VCC is going into that resistor. It's a thin trace, whereas the other traces coming into this VCC hole here is they're all larger or thicker traces. You could play around with the trace routing however you'd like. So for example, if I want this to be a little bit closer, maybe like this, so there's maybe more open space over here, or I could bring it down like that to try and get some kind of a more consistent pattern in how the traces are routed. Again, this is all aesthetics at this point. You do what you want to do. There is no right or wrong here. You could, for example, there's this little sort of kick over here. You could bring that down further if you wanted. You could bring it up further if you wanted. Again, this is all preference, personal preference at this point. Everything else is going to work fine. Everything's connected electrically. Everything should be fine. Now you're getting into the vanity aspect of PCB design. My thinking is I'm going to have multiple PCB designs that I release. There'll be this version, which will be the through-hole version, or the dual version. And then I'll do a different version of this PCB that only has the surface mount chip on it to maximize that area on the back for artwork. I don't know. We'll see. We'll see how the mood strikes. Other things worth talking about. These holes here, these drill holes that I've added to the PCB. They get in the way of things. There's a space here that I could be using that I can't because they're there. I could, if I wanted to, come in here and delete them. No problem. Again, they're there because they exist in the stock personality chip, and it gives something to clip into or hook onto. So people who want to add accessories to these custom personality chips, this gives you a mounting point for stuff. Oh, one thing that might be worth pointing out. So let's say you do decide you want to get rid of a drill hole, say, and you hit the delete key. Well, now you've got this really big hole here in this big copper plane on the back. You can tell Easy EDA to rebuild the copper plane. All you have to do is hit Shift and B, and that rebuilds the copper plane. The hole is gone. Or I didn't want to do that. I bring the hole back. Well, now Shift B again. Rebuild the copper plane one more time, and it creates room for that hole to be drilled through the PCB. And likewise, if that big mass of blue is distracting or getting in the way, you can hit Shift and M to hide it. The layer is still there. You can see maybe this. There's an outline here of dotted or dashed blue line. That still represents where the area is, where that ground plane is. But it's going to not show you the whole thing filled in. That way you now can see through that copper plane or that ground plane into the top side or the top layer of the PCB, and you can see all these red traces going through that. So that, I think, is about where it's going to be. I'm going to probably play with this just a little bit more. Not even play with it. It's going to be view it in 3D, view it in 2D, rotate it, spin it around, see what I think about it, see if anything looks a little off. For example, these corners here, they seem to be maybe a little too steep or too close to this. I'm going to double check previous designs of mine. I'm going to check the stock personality chip because I think I should probably be doing something closer to this, you know, maybe even all the way over to here, like that. And then I could bring these fingers down a little bit further to the edge of the board. So stuff like that I need to go and look at and see if that board outline is correct. I'm guessing I've got too much of a edge cut off there, too much of the corners cut off there, and I need to maybe undo that a little bit. So I think that's it for this video. In the next video, I will look at adding artwork and quickly putting together a surface mount only version of this personality chip. And maybe we can even get to the point where I finally place an order for some PCBs, because this thing has taken way too long and it's time to get this thing done. So until next time, have fun.